Hello everyone. So today we're going to look at arc length of a circle. So this is going to be classwork 6.5 and we're going to look at like a portion of the circle. So how long is a portion of the circle? Alright, here we go. So the circumference of a circle. The circumference of a circle is the distance around the circle. The circumference C of a circle is C equals pi times the diameter, or D, or C equals 2 pi r, because remember, diameter is equal to 2r, where D is the diameter of the circle and r is the radius of the circle. And the reason for this is that 2 pi is the entirety of the circle. Remember, as we go around, a whole circle is 2 pi around. Now, the radius of a circle is 11 inches, so we have r equals 11 inches. Find the circumference of the circle and round to the nearest hundredth. So circumference is equal to 2 pi times r, which is 11. So this is equal to 22 pi. And we actually need to put this into our calculators. I'm going to be using the yellow calculators today, the actual TI-84 pluses. You can use Desmos, whatever you like. But 22 pi, and just actually use pi, which is second caret right here, the button right below clear. And you get 69.12 when we round to the nearest hundredth. So this is approximately 69.12. All right, next one. The diameter of a circle is 4 meters, so we have diameter here, which means the radius would be half of that, or 2. Find the circumference of the circle and round to the nearest hundredth. So circumference here is pi times diameter, or 4 pi. We put that into our calculators, and we get 12.57. Approximately 12.57. Ooh, and I should put some units here. So this was meters, and this one is inches. The next one, the circumference of a circle is 6 meters. So this time we have C. Find the radius. So I need to know what r is equal to. So 6 is equal to 2 pi r. To get r by itself, we're going to divide by 2 pi. And I will get 3 over pi equals r. So let's put that in here. 3 divided by pi. And I get 0.95. 0.95. Which makes sense because 3 divided by 3.14 is 0.95. So r is approximately 0.95, in this case, meters. So I know you've probably done circumference before, but I just wanted to review that. Now, arc length in radians. The formula for arc length in radians is the length, or L, is equal to radius times theta, or our angle. Now, L is the arc length, R is the radius, and theta is the measure of the angle subtended by the arc in radians. It has to be in radians. Now, an entire circle is 2 pi. So this angle will be a portion of that. And we're always going to look at the angle that is less than 180. So generally, theta, if you're not given any other information, theta is going to be less than or equal to 180 degrees. So that should help you out a little bit. So let's identify what we know. The radius of a circle is 1, so r equals 1. What is the length of an arc that subtends an angle? Subtends just means it connects with this angle. Like this arc goes with this angle. An angle of pi 3 radians. So the angle, or theta, is pi divided by 3. So we plug those in. The length is equal to r, which is 1, times our theta, which is pi over 3. Now, we could just say this is pi over 3, but generally they're going to want you to round to the nearest hundredth. So 1 times this is just this, so it's pi divided by 3. And we get 1.05. 1.05. And it doesn't tell us what length that is there, so you can just write units. Okay. Continuing on. The radius of a circle is 13 meters. So this time we have units. And I know there's a really small picture here for you to see. What is the length of an arc that subtends an angle of pi 5 radians? So the r is 13. Theta is equal to pi over 5. And we plug them in. L is equal to 13 times pi over 5. So as we put that into our calculators, we have 13 times pi divided by 5, and I generally write it in the calculator just like it's written on the paper, and we get 8.17, approximately 8.17 meters. And again, we're finding this length right here, so that's the length right there. Before we found this length right here. Okay, next one. The radius of a circle, and sometimes they're going to give you the diameter, but in all of these they gave us the radius. The radius is 17 miles. What is the length of an arc that subtends an angle of pi radians? So pi radians, you know, is half of the way across. So here, 180 degrees are pi radians, so theta is equal to pi. So the length is equal to 17 pi, which is approximately, we're going to put that into our calculators, 17 times pi, which is 53.41, and this one is miles. 0.41 miles. So this time we did half, this half right here. Okay, second page. Now arc length in degrees. You convert the degrees to radians, so you always have to have it in radians. And then use the radian formula. Remember to convert degrees to radians, multiply theta, whatever you have, by pi over 180. And since we're converting to radians, the pi has to be in the numerator. But basically it's the same thing, except you're converting first. So find each indicated measure. If necessary, round to the nearest tenth. So first we're going to start with 60 degrees. So we have to convert it. So 60 times pi over 180. This reduces to pi over 3, because 60 over 180 reduces to 1/3. And now we're finding the arc length of AB. And again, generally you think of AB as the smaller arc, not that larger arc, just a smaller one. And so we do the length is equal to our radius, which is 8, times our theta. We put that into our calculators. 8 times pi divided by 3. And we get 8.34. And here it's centimeters. 8.34 centimeters. For our next one, we have 40 degrees. So first we need to determine this angle. They gave us the angle and the arc length, and we need to find the circumference here. So using the angle and the arc length, we can get the radius. Once we have the radius, we can find the circumference. So 40 degrees times pi over 180. This becomes 2 over 9, so 2 pi over 9. And so 4.19 is equal to whatever our r is times 2 pi over 9. So we're going to divide both sides by 2 pi over 9 or multiply by the reciprocal. So 4.19 times 9, and then we're going to divide by 2 pi, and we get 59.23. So r is equal to 59.23. Hope everybody's okay with that. Once we get 59.23, and I'm double checking that all of this is done right by going through each one and making sure I've done the correct work. And see, we have it. And that's why I know it's not 59. I knew 59.23 sounded too big. So it's 4.19 times 9. And then when we divide, and I forgot to do this in here, I have to do 2 pi in parentheses. And that's my bad. So it's 6.00 or just 6. So the radius here is 6. And I knew 59.23 was too large because it didn't look proportional. And that's how I knew it was too large. So the radius here is 6, and it's 6.00, so we're just going to say 6. Now that we have the radius, our circumference is equal to 2 pi r, or 6. So our circumference is equal to 12 pi. We put that into here. 12 pi is equal to 37.70. So our circumference is 37.70, and we're working in inches. So we're going to put inches there too. All right. The last one we need to find is the measure of, it says arc RS, but we already have the measure of arc RS, so we're actually going to find the measure of angle instead of arc, angle RS. That's what it's truly saying right here. So now that we know that, we are going to plug this into our equation. So our length is 44 equals our radius 15.28 times our theta. We don't know what theta is. So we're going to divide both sides by 15.28. And we get 44 divided by 15.28. And we get 2.88. So our theta is equal to 2.88. Now I could convert this back into degrees if I wanted to at this point. And to convert into degrees, I do 2.88 times 180 over pi. So let's see that. So that times 180 divided by pi. And I get roughly 165 degrees. It's 164.98. No, 99, sorry. 164.99. So theta is equal to 164.99 degrees. And the reason I did that is just because we were working with degrees the rest of it. Okay. Now that we have that, we're going to find the missing one. Round the radius, central angle, and the central angle to the nearest whole number. So this time we're going to do whole number. Round the arc length to 2 decimal places. And you can use pi or 3.14 here. Doesn't matter. Okay, so like I said, we're always going to be looking for the smaller angle. So here we're going to be looking for, or the smaller arc, we're going to be looking for this arc. So first I have to figure out what this angle is. Well, whole circle is 360. There's 360 minus 210 is 150 degrees. So now that we have that, we have a little bit more information. So central angle is 150 degrees. My radius is 15 inches. Let's convert the 150 to radians. So 150 times pi over 180. This reduces to 5/6. So it's 5 pi over 6. And now we need to find the length of the arc PQ. So length is equal to 15 times 5 pi over 6. We're going to put that into our calculators. 15 times parentheses 5. If I do the right parentheses, 5 pi divided by 6. And I get 39.27. And it said round to the 2 decimal places. 39.27. I'm going to use pi instead of 3.14. You guys can choose to use either. And here we're using inches, so I'm going to put inches on both of these. Now, I would really suggest you guys do 2 and 3 by yourself. So pause the video and try and do 2 and 3. If you keep going, do 4, 5, 6 as well. But pause the video so that you can get a practice with this. Okay, the radius here is 17 meters. The arc length is 15.87. Now, we've been using this cursive L for arc length, but sometimes you're going to see S as well. Arc length can be identified as S. I don't know why they use S. I've never quite understood it. So this is also in meters. We're going to plug these in and find the central angle. And we're going to round to the nearest whole number, hopefully. All right, 7 meters, 15.87. So 15.87 is equal to theta 7. Divide both sides by 7. And we get 15.87 divided by 7. 2.27 for theta. Now, one thing is this doesn't have a pi in it, so to get a pi in it, we divide by pi. Because otherwise we'd be multiplying by pi. And there's no great way to do this, so it'd be 0.72 pi, which we can write that, but it says whole number, so I'm just going to write this as a whole number, which is 2 radians. And you actually have to write out 2 radians. I don't like rounding it to whole numbers, ideally, but sometimes you're going to be asked to do that, so I want you to see everything. All right. The central angle here is 50 degrees. We also could change this to, let's go back real quick. We can also change this to degrees. So let's do that. So 2.27 times 180 over pi. Let's see what happens there. 2.27 times 180 divided by pi. And we get 130 degrees. So this is also 130 degrees, which I'm okay if you did that as well. So here our central angle is 50 degrees. Our arc length is 9.6 centimeters, so we need to find our radius. So 9.6 is equal to theta. 50 times pi over 180 is equal to 5/18. So 5 pi over 18. That's what we need to use. They're equal. I guess I don't need to use the slash. So 5 pi over 18 times r. So we're going to multiply both sides by this reciprocal. So we get 9.6. Reciprocal of that is 18 divided by 5 pi. So times 18 divided by 5 pi. And remember, because I didn't do this last time, you need to put that in parentheses. And you get 11 roughly. 11. So 11 centimeters. Okay. For the last two, we're finding the length. Or the last three, sorry, we're finding some lengths of the arcs. So here, we need to convert all of these first to radians. So 160 times pi over 180. This is 8/9. So this would be 8 pi over 9. So our work would be length equals 20 times 8 pi over 9, which is equal to 160, but that's fine. So 28 pi divided by 9, and I get 55.85. 55.85. We are working in feet, so feet. And the dogs decide to go a little bit crazy right now. For the next one, 40 times pi over 180 is equal to 2 pi over 9. So our work is length is equal to 5, because that's our radius, times 2 pi over 9. 5 times 2 pi divided by 9 is equal to 3.49 meters. And then the last one, we're doing 85 pi over 180. 85 over 180, I don't know what that reduces to off the top of my head, so I'm going to put it in here, press math, enter, enter, and it reduces to 1736, not 1738. So 17 pi over 36, and I get length is equal to 14 times 17 pi over 36. Plug that in. A lot of this is just going to be plugged into this formula. So once you get the formula, you're pretty golden. And this one gives you 20.77. Okay, this one's centimeters, so put a C there. All right, well, that is it for today. I hope you have a fun time doing the activity, and I will see you guys tomorrow. Have a good one.